We know vectors are the physical quantities which has both magnitude and direction and satisfies certain laws of vectors. It's not sufficient for a vector to have just magnitude and direction, but it shall satisfy certain rules. Now we are going to learn what are that rules are. It's like simple vector laws of addition. There are certain vector laws of addition. In the case of the addition, vectors are supposed to follow certain rules. That rules like commutative law means what? Adding a vector a bar plus b bar is similar to adding a vector b bar to that of the a bar. Let us try to understand first of all that how do you add a vector. Say for example, you have a vector a, you have another vector b. Now I want to add these two vectors. They can be added based on the vector algebra, but let us try to understand using a basic method called something like graphical method. We may not use this method every time, but anyway, to understand that, let us try to use a graphical method. So what we need to do, how do we have to add the vector is, say vector a is there, I want to add the vector b. So what I am going to do is shift this vector b, I am going to shift it in such a way that the tail of the second vector is at the head of the first vector. But while we are shifting, we don't like to disturb either its magnitude and direction, then only it can become a similar vector. So what we are going to do is just shift the b here. I have not changed its magnitude, I have not changed its direction, magnitude is same, direction is same, just I have shifted a vector parallelly. By shifting the vector parallelly, as magnitude and direction remains same, vector also remains same. Now if I have to add these two vectors a bar and b bar, simply we need to add the tail of the first vector to the head of the first vector, head of the second vector. So this is nothing but equal to a bar plus b bar. This is one way of adding the vectors. Suppose you want to say b bar plus a bar. So what I am going to do, b bar, this is a bar plus b bar. Now I want to get b bar plus a bar. So what I will do now differently is I am going to keep the b bar as it is. I am neither going to shift its magnitude nor going to shift its location, neither the direction. I will just keep it as it is. Now I will shift this vector a bar because I want to add a bar to b bar in such a way that I will shift the head of the a vector to the tail of the b vector, something like this. This vector a is similar to that of this vector. I have not changed its magnitude, I have not changed its direction, I have just changed its location by shifting it parallelly. Now if I want to say b bar plus a bar, the head of the first vector has to be added with the tail of the second vector. This is b bar plus a bar. It's very clear from the above discussion that it satisfies commutative law, that a bar plus b bar is nothing but equal to b bar plus a bar. This way we can add vectors using a graphical method. It not only satisfies commutative law like we have mentioned earlier, it also satisfies other rules like associative law. Associative law tells you that if I have to add a vector a bar, b bar and c bar, first I will add a bar and b bar. To that combination I will add a c bar. It doesn't make a difference in the other way also. First add b bar and c bar and then add to that of the a bar. You are going to get back to the same result. That law is called as a associative law. We have also had another law called something like distributive law. It is simple. Say you are having a constant k. You want to add to the combination of a bar plus b bar. You add that constant to a bar, add that constant to b bar separately, and the summation of the two vectors is nothing but the commutative law. This is going to be the same. This rule is called something like a distributive law. There is some other law called something like triangle law. This triangle law simply tells you that if there are three vectors acting on a point, say this is a point, say this is a vector A bar acting on this point, there is another vector like B bar acting on the same point, there is another vector C bar acting on the same point, and this point is in equilibrium. This point is not moving, it's not at all having any resultant force. Then these three vectors can be represented as three sides of a triangle, but rule taken in the same order, but rule is called something like a triangle. Let us see how do we do that. I would like to shift these vectors now parallelly. I know when vector magnitude and direction is kept intact, it's not going to change. Therefore, I will shift this vector now A bar here like this. I have not changed A bar in any way because its magnitude is same, its direction is same. Now I am going to shift this B bar like this. Like this. I am going to shift my B bar like this. Though the diagram doesn't look exactly similar, I am just changing neither changing the magnitude nor changing the direction. I have just shifted the vector B bar in parallel to that of the earlier vector. As I have not shifted the magnitude, as I have not changed the magnitude and direction, it's going to be the same. So what I have done, I have shifted the A bar to here, I have shifted the B bar to here, and I am going to shift the C bar to here. Let us shift the C bar. See, I have just drawn the same vector, same magnitude and same direction. I have just shifted the vectors parallelly. Therefore, you can see this is vector A in a specific direction, vector B is in continuation, vector C is also in continuation. This rule is called something like a triangle of vectors. It simply tells you that if the three vectors are acting on a point and the point is in equilibrium, then the three vectors can be represented as a three sides of a triangle taken in a order. There is one more rule. We will discuss it in the next post. Right? Thank you.